Hey there, Nate from Microchip Technology here to talk about how the AVR SD protects its memory for safety-critical applications. Electronic memory is a ubiquitous feature of microcontrollers. It's everywhere. It's used for programming and running devices, saving data, caching information, and more. But what happens when it gets corrupted? A few bits get corrupted in a device with thousands, millions, or even billions of bytes doesn't sound too drastic at first. But when that corruption occurs, it's impossible to predict if the corruption happens in an unused register or in a system-critical portion that is vital for a device to function. And for functional safety, leaving memory corruption to chance creates unnecessary risk that could compromise a system and risk harming people or property. How might these corruptions occur? Well, memory can be compromised by electrical noise or power fluctuations and voltage spikes, and hardware can also degrade over time due to read and write cycles. And stranger than any of those possibilities, even cosmic radiation, as in tiny charged particles from space, can flip bits and cause errors. Fortunately, these events usually are insignificant when it comes to devices like laptops or cell phones, but when a system is responsible for core safety functions, this typically insignificant event could become much more severe. So how does the AVR SD protect from these kinds of errors? Well, the AVR SD uses an important feature called error correcting code, or ECC for short. This protection provides a way to shield a sensitive system from memory corruption errors. The AVR SD's ECC works by adding extra bits for protection. After user data is stored to memory, that data and the data's address is used to calculate an ECC value that is used later during read instructions to verify the data integrity. These checks are done during any read cycle, so the user doesn't need to worry about enabling or instantiating this feature. However, it is up to the designer to configure how a system responds to certain conditions, such as when an error from memory is received. This system can repair single-bit errors in user data and detect, but not correct double-bit errors or errors in the ECC address, which makes this ECC protection single error correcting, double error detecting, or SecDed for short. Now we've covered how ECC protection works at a surface level, what happens when an error occurs, and how does SecDed ECC protected memory respond to an error. Well, in practice, the ECC protection looks a lot like autocorrect on a cell phone. When you type a word into your phone and miss a letter, often the phone can fix it. But if the error is slightly larger, the phone may not autocorrect, but instead simply mark that the word is misspelled. Data inside memory doesn't necessarily look like words in a text message, but the principle is similar. If a bit gets corrupted in a piece of data, the ECC system flags that an error occurred and corrects the issue. And if the error is 2 bits, it won't be able to correct the error, but it will still flag that an error occurred. This error can be picked up by the error controller, which we covered in this series' previous video linked in the description. To further aid developers, the AVR SD's ECC memory also supports error injection as part of the ECC hardware to ensure expected behavior for both single and double bit errors. Error injection is discussed in more detail in the previously mentioned error controller video, and information for how this is done can be found in the non-volatile memory controller section of the AVR SD datasheet. Additionally, for easier testing for developers, error injection is also included as part of the AVR SD Safety Framework software available on the AVR SD family page. Now, we covered how data corruption can present risk or cause harm earlier, but let's return to that idea and talk about why SecDed ECC memory protection is important in certain applications. Generally speaking, ECC protection is a versatile tool for any safety-critical application since it prevents silent memory corruption over time. But to be more specific, it's especially common in automotive, industrial, aerospace, and data center applications. But regardless of where it's used, ECC's protection provides multiple key benefits. ECC protection ensures data integrity and reliability by protecting against bit flips caused by electrical noise, aging hardware, and radiation, and it helps prevent silent memory corruption on the AVR SD's onboard flash, SRAM, and EEPROM memory from these factors over time. It helps with safety compliance since ECC protection is a part of safety standards such as ISO 26262 and IEC 61508 and is essential for ASIL-C and SIL2 applications. It provides real-world benefits by ensuring reliable performance for automotive, industrial, and home appliance applications, reduces undetected errors that can cause faulty systems, and enhances overall system safety by preventing unexpected failures. In short, ECC memory is a valuable tool on the AVR SD that aids overall system integrity, enhances reliability, and helps meet safety regulations. That covers how the AVR SD protects its onboard memory using ECC protection. However, ECC memory is only one component of a functional safety design and only one aspect of the AVR SD's many functional safety offerings. So, if you're looking to learn more about how the AVR SD supports safety critical designs, check out our previous videos where we cover how the AVR SD supports ASIL C and SIL 2 compliance for the ISO 26262 and IEC 61508 standards, and how the AVR SD's error controller detects, manages, and tests faults. And stay tuned for another upcoming video where we'll talk about how the AVR SD's enhanced safety features support safety critical applications. If you want to learn more about functional safety, our functional safety courses are available on Microchip University. If you want to get started developing on the AVR SD, you can start with its Curiosity Nano development board. And if you want to learn more about the AVR SD, check out its family page, where you can find more information and the device datasheet. Thanks for watching, and if you like this content and want to see more, please don't forget to like, comment, subscribe, and ring the bell for notifications on future videos.